make the rectangles go to infinity, okay, and then we actually call that an interval. Okay, I'm going to let you guys read some of these maybe on your own, but if you're reading this is, see, I said extremely important. You might even say the most important. Area under a curve, and no accumulates distance. And accumulates distance, that means the key to finding total distance traveled. Okay. Really, our goal today is to find the area under the curve, and if it's not a rectangle and it's a triangle or it's not a trapezoid, we're going to have to use an approximate method. That's the gist of today. Okay? Are you with me so far? Flip the page. Okay, so this is a nice little example of how we do rams. What in the world's a ram? The AP exam won't call it a ram. They'll call it approximation method. So when I say LRAM, that's a left rectangular approximation method. An RRAM is a right rectangular approximation method. An MRAM is a middle. I have them right here. LRAM, RRAM, MRAM. Okay. So here's the idea. We're trying to approximate this. This is a nice picture of area under the curve, correct? We don't have a way to do that. So what we do is we break up the curve into rectangles because we know how to find the area of a rectangle. If possible, we try to make them rectangles, but that takes a little bit longer. Do you see how this is a better approximation for this because it leaves less gaps in the area? Okay. This is a good summary of the process. And just like before, we're going to do this with graphs. We're going to do this with equations. And we'll do them with tables. I'm going to show you how to do it with a table. So step one, we are going to divide or partition the interval into n subintervals. Step two, we're going to create n rectangles whose base equals the width of each subinterval. We'll do one in a second. And then step three, we're going to find the areas. So let me show you how they work. Here is 3 pictures of an example of 5 over x. This is not doing this. Go. So let's first do a left rectangular approximation. Okay. We are going to approximate from 1 to 5. So here 1, 2, 3, 4, 5. And I would like us to use 4 rectangles. The width of each of the rectangles is going to be then 1, right? From 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5. To do an LRAM, what I do is I'm going to look. My interval starts at 1. Agreed? So I'm going to write my interval out. I have 1 to 2, bless you, 3 to 4, and 4 to 5. On the interval from 1 to 2, which number is on the left side? From 1 to 2. Which number is on the left side? 1. So I'm going to use that left number 1, and I'm going to pull that up to where it hits the curve. That is the height of my rectangle. So I cross then. From 2 to 3, what is the left endpoint of that interval? 2. So I'm going to go from 2 and I'm going to make my rectangle as high as when it hits the curve. So that's where 2 curve. From 3 to 4, I use 3, where that's going to be where 3 hits the curve. And from 4 to 5, I'm going to use 4. Since this is a decreasing function, this is going to be an overestimate. An LRAM will always be an overestimate because it's going to hit the endpoint at a higher spot and is decreasing. Okay. Here's an easy way of doing this. How do I find the area of a rectangle again? Length times width, right? What's the width of all of these? So it's going to be 1 times 1 times 1 times 1 times, and then after the end I'm going to add up the total area. Okay. How am I going to find the height? Anybody know? Plug in the left endpoint to the function, because that's how. This is 1 times 5 over 1, which is 5. What's 1 times 5? 5. Okay. This is going to be 1 times 5 over 2, because the function is 5 over x, right? This one's going to be 1 times 5 over 3, and this one's going to be 1 times 5 over 4. Okay, to save ourselves a little bit of work, let's just go ahead and we're going to use, do you want to use the 1 times it? All right, let's just add those 4 numbers together then. Okay, make sure you use a squiggly. Why? This is definitely approximate 10.416 repeat. How are we doing? Okay, can I show you an RRAM? Yes. Okay, I don't know if I'm going to show you an MRAM yet. I might start to show you it. Here's the deal. The 3 most important ones are LRAM, trapezoid approximation. I very rarely have, I don't know if I've ever seen an MRAM where you have to use a midpoint, but it's not hard to do. I'll show you how to do it. Okay. Rectangular approximation works the same way. I still have 1, I still have 2, I have 3, I have 4, I have 5. I still wanted 4 rectangles, so I still have intervals 1 to 2, 2 to 3, 3 to 4, 4 to 5. But this time, for the height of my rectangle, this R in front means I'm going to use the right at the end of the interval. So on the interval 1 to 2, which number is on the right? The 2. So my first rectangle on my 1 to 2 rectangle is actually going to be as high as that right endpoint. So then I make my rectangle kind of go backwards. Okay, once again, what's the width of all of these? 1. To find the heights, instead of plugging the left number in, I'm going to plug the right number in. So this is 1 times 5 over 2. This is 1 times 5 over 3. This is 1 times 5 over 4. This is 1 times 5 over 5. Is that making sense? Can you calculate the area for this one then? Six 417. If I'm doing exact, it was a 6 repeating, right? Yeah. But 416 or 417 if we're using the rounding or truncating. Is this an over or under approximation? Okay. And so, by the way, sometimes we wonder, maybe is an MRAM the average of these two? Let's average those two together and see. I'll just do this. So I'm wondering, is an MRAM going to give me about an 8.416? Because wouldn't you logically think, hey, if I wanted to do better, I could just average the over way of thinking about it. But what I want to show you is that an MRAM does not necessarily equal that, because we're not going to get that for the MRAM. I think we can do it. We have time. Same deal. 1, 2, 3, 4, 5. I still have 1 to 2. I still have 2 to 3. I still have 3 to 4. And I still have 4 to 5. What does MRAM imply? What would be exactly in the middle of this interval? 1.5. So if I would go to 1.5 and make my rectangle that high, let's do it. 2.5. 3.5. 4. It would look something like that. Oh. These are all 1 wide again, right? This time, though, I used 1.5, so the height of my rectangle is going to be 5 divided by 1.5. What is it going to be here? 5 divided by 2.5. 5 divided by 3.5. 5 divided by 4.5. What do you get for this? So it is not an average of the LRAM, because depending on what the function is, it sometimes could be if it was like a constant rate of change. But on something, nope, it's not going to be. All right, good. We're not doing all of this today. We are going to end with this table. Okay. Now, here's the problem with the table. Look, hey, cool, it's a velocity table, right? So if we would find the area under that velocity table, what should it give us if we added it all up? The what? Total traveled, okay? So we are trying to find the total distance traveled. Estimate the distance traveled by the engine, okay? I do not have a function. I don't have a curve to draw. However, do I have the actual velocities? I do. So what we're going to do is I'm going to just show you with an LRAM, and I'm going to tell you that an RRAM is going to be the same. Hopefully you'll see why in a second. I wanted 10 rectangles. So if this goes from 0 to 10 seconds, what should our intervals be then? 0 to 1. Would you write out the 10 intervals? 0 to 1, all the way up to 10. And I'll leave some room here.